Today we are going to work on section 7.3, which is the second method for the algebraic solving of a linear system. I have two wordings up here. One of them is linear combination. The other one is elimination. I will be using both wordings when I talk. I will use both wordings in my tests, my quizzes, because the author uses both in the textbook. I want you to be familiar with both. Linear combination means that we are going to combine equations together by adding them together. I think the book also says addition and subtraction. Solve linear systems by addition and subtraction. But we're going to combine these equations so that we can eliminate one of the variables. Thus we can solve for the other one. Just like we were doing in section 7.2 with the substitution, we would substitute one equation into the other one so that we could get rid of the variables and have just one variable left rather than two variables. We want to eliminate one of our variables. So if I tell you to solve by linear combination, what we're going to do today, we're going to add our equations together. That's what you will be working on. This is kind of a two-step process. Today we're going to be working on just adding them together. When we get together in class on Wednesday, we're going to work on adding them together when they're more difficult. You'll see that in just a little bit. Your quiz tomorrow is only over 7.1 and 7.2. That's the graphing and the substitution. Don't use the method that I'm teaching you today on the quiz tomorrow, because I will not count your answer correct. In fact, you'll get the problem wrong because you can't show me how to use substitution. I've had students do that in the past, and so I'm just warning you. Okay? Make sure that you're graphing to show me the solution for the linear system and that you're using substitution. What we're learning today is not on the quiz on Wednesday. Jot down the system, 3x plus 4y equal 8, and negative 3x plus 5y equal 10. It is important that your x's are lined up, your y's are lined up, your equal signs are lined up, and your constants are lined up in order to do linear combination. It is important that every section of the equation is lined up, including the equal sign. You'll see that in a few examples a little bit later from now. We're going to add the two equations together. When I add those two equations together, I got 3x and negative 3x right here that I'm going to add. What happens with 3x and negative 3x, ladies and gentlemen? They cancel. We get 0. So those are totally gone. How about 4y and 5y? Is it a negative or a positive? It's positive. It's a positive 9y. How about 8 and 10? Yeah, I almost gave you the answer there because that's what I was thinking. Okay, so I've got a one-step equation now. 9y equals 18. Just by combining the two equations together, a linear combination. Combining of two lines is what we've just done. All right, what is y equal to then? 2. Now, we are going to substitute, just like we did in 7.2, we're going to substitute what y is equal to in for y, and you can do it in either equation. It does not matter which equation you're putting it back in for. Which one should we substitute in? Any preferences? Top one. Maddie, why do you say the top one? Because there are positive numbers in it. Okay. So let's do the 3 times x. I don't need parentheses here. We have 3 times x plus 4. That's where my parentheses need to go. And in for the y goes the 2 that we had just found. And 4 times 2, class? 8. Equals the 8 on the other side. What happens when we bring that 8 to the right? We get 0. So we have 3x equals 0. And when I divide by 3, what do I get? I still get 0. Okay, our answer should be 0, comma, 2. Check it in both equations to make sure it works. I'll stop for a moment so that you can check. Does it work in both equations? Awesome. then this is our answer. Now, do you like that a little bit better in substitution?
Yes.
Yeah. It's a little slicker. Now, therefore I caution you, don't use this on my quiz tomorrow. I need to know if you know how to do substitution. Okay, I'm testing substitution and graphing tomorrow. I will test 7.3 and what we'll study on Wednesday, 7.4, in another quiz later on. Okay, so I will test this, but not tomorrow. Let's go on to this one. We have 4x minus 3y equal 5 and negative 2x plus 3y equal negative 7. Please jot down the system. And I want you to go ahead and add the two equations together and see if you can start solving it. Feel free to talk to your partner. Feel free to check with your partner, especially once you're done. All right, we have the answer of negative 1, negative 3 as our xy pair. And we have the combining of the two equations to find out x equals negative 1. Everybody did that. And then substitute back in, find y equals negative 3. Any questions here so far? A little easier than the substitution method, isn't it? Yes. All right. Here's another one. We have 5x plus 6y equal 4 and 7x plus 6y equal 8. Now, take a look at this. Does anybody have an issue with this system? Have any issues with this system along the way? Christine?
None of them cancel out.
Ooh, none of the variables cancel out. Okay. Let me give you a little mathematical thing that you can do in order to make all the variables cancel out. Pick up that red pen or other color. You'll want that other color pen right now. You may multiply either equation through by a negative 1. Which equation should we multiply through by? Top one or the bottom one? Any choice? No, it does not matter. Bottom? Okay. Negative, negative, negative. All of the signs flip, remember, when you multiply through by a negative. So now, if you add your equations together, what are you going to have for your x's? Negative 2x. What's going to happen to your y's? They cancel. What do you get for your constant? Negative 4. So x equals 2. Life is good. Now, when you substitute that 2 back in, you may put it back in for x in the first equation, or for x in the second equation, the original one, or you can put it back in the one with all the negatives. May I just give you a hint? Don't do the one with all the negatives, because that's where kids usually goof up. Okay? You can put it in the original 7x plus 6y equal positive 8. Or put it in the top one where all the positives are. But if you put it in the one where your negatives all get, you just put it in. Sometimes kids make mistakes because of all the negatives. I just gave you a hint there. It'll get you a correct answer as long as you do your math right. Which one shall we put it in for? Any preference? Andy, top one? Okay, so 5 times 2 plus 6y equals 4. 5 times 2 class is 10. 10 plus 6y equals 4. Bring that 10 to the other side. What do we get? Negative 6, and therefore y is equal to? Awesome. And so we'll have our answer of 2 comma negative 1. Of course, you will check the x and the y in both equations, especially when you're doing your homework and when you're taking my quiz and my test, to make sure that you get 100% on that problem. Okay. Any questions? Andy?
When you're checking and you're putting them in, do you put them in with the original equation or with the negatives?
You should use the original equation. Okay, you should. Will you get the same answer even with the one with the negatives? Yes, you will. It should work with all of them. I don't like to substitute back into where I just put in a whole bunch of negatives because I'm fearful of multiplying incorrectly. Any questions there? All right, then why don't you guys do this one? 7x minus 2y equal 5, and 7x minus 3y equal 4. I'll pause here so that you can work. We came up with the solution of 1, 1. Notice that when you multiply through by a negative, you have to change all of the signs up here. And that is what Samantha did on this one. So every negative became a positive, every positive became a negative. So you can see that. That gave her x's to drop out, and her y's left her with 1 times y equals 1. Boy, that was easy math. and then substitute it back into one of the two equations. She chose the top one to find out that x is equal to 1 as well. Any troubles there? Well, you guys are going to slide right through your homework today, aren't you? Fabulous. Let's look at this one. 9x minus 3y equal 18, and 3y equal negative 7x plus 30. Take a look at that system and tell me if you have any issue with that system. An issue with that system at all? What do you say, Samantha?
They're not all lined up.
What do you mean they're not
I mean,
all
like-
lined up?
Sorry, you said that the equal sign and all the constants and variables and stuff have to be lined up, and they're not.
Okay, that's right. All of the variables should be lined up, and the important thing here is that the equal sign needs to be lined up too. Do I have a volunteer to come up and rewrite that second equation so that things are lined up the way they should be? Do I have a volunteer to come up and rewrite that second equation? Okay, what's causing us troubles? We need x and y on one side. We need the equal sign and the constant on the other, because that's how the top equation is. X and y on one side. Any thoughts on what you're going to do there? How can I move that negative 7x so that it's over to the other side, Maddie? You want to go up and write it how it's supposed to look for me? All right. Okay, thank you. So looking at this problem here, we have to add 7x to both sides. The way to do that is to bring that 7x over. Now we can forget about that equation. Okay, we're not going to worry about that middle equation any longer because Maddie just rewrote it. And notice how what she also did. She put the x's so that they are lined up, the y's so that they are lined up. She's got her equal signs lined up and her constants. That was a very good way to write this. So 9x and 7x classes, 16x. What happens to the y's? They cancel. 18 and 30 gives us class 48. And when we divide, x will be equal to 3. Which one should we turn it back into, substitute back into? Any preference? I've heard a couple different things. You can put it back in for x here, you can put it back in for x here, or you can put it back in for x there. It does not matter. The 7x plus the 3y. So 3y equal 30. That means that we got to put 7 times 3 in there. 7 times 3 classes. Do you guys agree with Andy? I need some more people in here. 7 times 3 is 21. 21 plus 3y gives us 30. When you take that 21 to the other side, what do we get? 9, and then y is equal to 3. So we will have our answer of 3, 3. Any troubles there? Any troubles at all? Do we need another one like that where we have to move variables over? No? Okay. Then I'm going to stop this